Dear students, today we are going to learn about the applications of derivatives in economics. In terms like demand or marginal demand, marginal supply and revenue, etc. we have already learnt in 11th standard. Let us revise it again. First, demand function. We know demand is a function of price, or demand depends on price. So, D can be written as F of P. And marginal demand is given by the change in demand with respect to price. So, dm represented by dm, which is equal to derivative of D with respect to P. And supply function, that is S is a function of P, and that is supply is also a function of P. And marginal supply is given by derivative of the supply with respect to P or price. Next, cost function. Cost function C is equal to F of X, where X is the number of items produced, and marginal cost is given by Cm is equal to derivative of C with respect to X. And total revenue R is equal to P into D, where P is the price and D is the demand or demand function. Now, average revenue can be calculated by total revenue divided by D. And revenue is nothing but P into D. P into D upon D, which is equal to price. So, average revenue is equal to price itself. Now, total profit is given by R minus C. Total revenue minus total cost. Now, price elasticity of demand, or simply elasticity of demand. Let us have some idea about this. And the law of demand states that as the price of a product increases, the demand for that product decreases. And consequently, as the price of a product decreases, the demand for that product increases. Now, therefore, the law of demand defines an inverse relationship between the price and quantity factors such as demand of a product. Now, the elasticity of demand measures how factors such as price and income affect the demand for a product. And especially price elasticity of demand measures how the change in a product's price affects its associated demand. And price elasticity of demand or elasticity of demand is denoted and calculated as, it is denoted by the letter eta. Eta, it is called eta. Eta is equal to minus P upon D into derivative of D with respect to P, where D is the demand function and P is the price. And this elasticity of demand also has been learnt in 11th standard. Let us learn some important points related to this price elasticity of demand. First one, demand is a decreasing function of price, means as price increases, demand decreases. So, d by dp, that is derivative of d with respect to p, will be less than 0, because we have already learned the increasing and decreasing function and their conditions. So, if it is a decreasing function, then the first derivative is less than 0. Also, price P and demand D are always positive. So, we can see price is positive, demand is positive, and this d by dp is negative, but there is already a negative sign in the formula. So, negative into negative, positive, means eta or price elasticity is always greater than 0 or positive. Next one, if eta is equal to 0, that is elasticity 0, it means the demand D is constant function of price P. That means there is no change in the demand even if the price increases or decreases. So, eta will be 0 in that case, and d by dp will be 0, since derivative derivative of a constant is 0. That's why d by dp will be 0. So, eta is equal to 0. In this situation, demand is perfectly inelastic. There is no change. Inelastic means no change. Now, third one, if 0 less than eta less than 1, that is, if the value of eta lies between 0 and 1, then we say the demand is relatively inelastic. That is very less value, very small quantity or very small number in between 0 and 1. It is very small number. So we say that demand is relatively inelastic. And if eta is equal to 1, the demand is exactly proportional to the price and demand is said to be unitary elastic. And if eta greater than 1, the demand is relatively elastic. A greater than 1 means little big. So the demand is relatively elastic, means there is change in demand with respect to price. Now, there is a relationship between marginal revenue, average revenue and elasticity of demand. So let us learn that relationship between these three quantities. We have RM. RM means marginal revenue. Marginal revenue is the change in revenue with respect to demand, where R is equal to P into D. Therefore, RM is equal to D by dd of P into D. We substituted R is equal to P into D. And we will differentiate this quantity, that is P into D is the product of two quantities, that is product of two functions P and D. So we will apply the product rule or UV rule. Here P is U and D is V. And here we are differentiating this function with respect to D. So the derivative of D with respect to D will be 1. So first term P into first function into derivative of D, that is 1, into second function D into derivative of first, that is dP by dd. And P is common. If you take P outside, then P into first term will not contain P, therefore it is 1 plus. There is no P here in the second term, so we will divide a P. To get the relationship only, we are just rewriting this function this way. So D by P. If you take a P out, then you have to divide a P in this quantity because there is no P in the second term. And consider this as an equation number 1. Now, eta, what is eta? Price elasticity of demand. Eta is equal to minus P by D into dd by dP, and we have got it as D by P into dP, just reciprocal. So take the reciprocal on both sides, then we will get negative 1 upon eta is equal to D by P into dP by dd. And substituting in this quantity in equation number 1, we will get Rm is equal to P into 1 minus 1 by eta, because here it is positive. So we have removed this negative sign to the other side, then it will become minus 1 upon eta. So 1 minus 1 upon eta, and we know P is nothing but average revenue, that we have already learned in the previous step. So P is equal to average revenue. So we can write Rm is equal to Ra into 1 minus 1 by eta. That is the relationship between marginal revenue, average revenue and price elasticity of demand. Next one, marginal propensity to consume. For any person with income X, his consumption expenditure EC depends on X. That means the daily expenditure or the expenditure on the daily consumption of goods depends on the income. Therefore, we can say EC, that is the consumption expenditure, is a function of X, where X is the income. Now, marginal propensity to consume MPC refers to the ratio of change in consumption of a good or service to the change in income of consumers. That means the expenditure changes with respect to the change in income. Therefore, we can write MPC as derivative of EC with respect to X, that is change in expenditure with respect to change in income. Now, average propensity to consume APC refers to the ratio between the total consumption to total income, that is EC upon X. APC is equal to EC upon X. Next one is marginal propensity to save. If S is the saving of a person with respect to income X, then marginal propensity to save MPS is the ratio of the change in total saving to change in the total income, and is given by MPS is equal to DS upon DX. And average propensity to save APS is the ratio of total saving to total income, and is given by APS is equal to S upon X. Now we have income is equal to expenditure plus saving. So X is equal to EC plus S. Now we differentiate both sides with respect to X, then the left hand side will become 1 and right hand side DEC upon DX plus DS upon DX, and 1 is equal to DEC upon DX is marginal propensity to consume plus DS upon DX is marginal propensity to save is equal to 1. That means marginal propensity to consume and marginal propensity to save is equal to 1. And also X is equal to EC plus S, and we will divide both sides by X, then 1 is equal to EC upon X plus S upon X, and EC upon X is nothing but average propensity to consume, and S upon X is average propensity to save. That means average propensity to consume plus average propensity to save is equal to 1. And the sums related to this topic is solved in the next video. Thank you.